All right, let's do a crash course on conversions real quick here, right? When you want to convert uh, degrees into radians and radians into degrees, okay, there's got to be a conversion rate. And when we talk about a conversion rate, we mean there's always an equivalent statement, right? So 12 inches is equal to 1 foot. We all know that. If you were asked to convert 78 inches into feet, there's a lot of us out there that would probably just say, well, divide this by 12. That'll tell you how many feet it is. When you hopefully in science class at some point, or maybe in a previous math class, you learned about how to do conversions by multiplying by a conversion rate. Okay. And what that means is take the unit that you're starting with, put that unit on the bottom of this fraction, right? This rate, and then on the top put what it is equivalent to in some other unit. So 12 inches is 1 foot, and I can multiply. And now when we multiply here, we can make this a fraction by just putting a one underneath it. We don't put 1 foot. It's not 1 foot. We just put the number one to make it a fraction. And then when we multiply fractions, we multiply across, and we can cancel the units that are similar. We can cross cancel units that are similar so that when we end up multiplying here, we end up with 78 over 12. And the only unit we're left with is feet. And 78 divided by 12, you can type that into a calculator, or you can, reduce it, do whatever you'd like. You get 6.5 feet, right? So doing conversions old school way, rather than just plugging it into Google and saying, what's 78 inches in feet? We multiply by a conversion rate. So let's talk about the conversion rate between degrees and radians. All right, we know that 180 degrees is equivalent to pi radians at this point. Okay, if you haven't talked about that, go back and take a look at some of the other videos. So the conversion rate is 180 degrees over pi, or it's pi over 180. It all depends on what you're starting with. So to convert 150 degrees into radians, we're going to multiply it by our conversion rate. Since we're starting with degrees, the 180 goes on the bottom and the pi goes on the top. And then we put this over 1. We multiply straight across. We won't take any shortcuts here. We get 150 pi over 180. And these degree symbols, these are our units that cancel. Now, this is radians, but like we've mentioned previously, we don't actually write radians. Anytime we see pi included in anything that has to do with angles, we just assume that it's in radians, right? And 150 divided by 80, those are both divisible by 3. We would get 5 pi, or 30, excuse me, 5 pi over 6. Okay. And again, this is radians, right? But we don't have to write it as such. We can just say 5 pi over 6. All right. Same thing here for 270. We're starting with degrees. So we put pi over 180 degrees, multiply. Now, what does this end up being? Really, all it ends up being is trying to reduce this fraction and slapping a pi on with the answer. Okay. 270 over 80 over 180. Okay. Both of these are divisible by 90. We get 3 over 2. Now, whether you put the pi on the top or whether you put the pi next to it, if you're in my class, I'm going to have the pi in the numerator of that fraction. I'm not going to write it next to it like this. And I'm going to say that's 3 pi over 2. Some people say 3 halves pi. Okay. I say 3 pi over 2. Okay. Let's continue. Radians into degrees. Now we're starting with a pi value, okay? So now since we're starting with pi, and this is partly the reason why I like to keep it in the numerator, is if I keep it in the numerator and I want to convert into degrees, I take that same conversion rate, but now the pi goes on the bottom because that's what I want to cancel out, right? So when we can cross cancel these pi's, multiply straight across, we get 540 over 4, which is, what is that, 135 degrees? Sorry, I should have had that degree symbol there, right? 180 degrees over pi. The degree symbol is not canceling now, right? So that goes with my answer over here. 7 pi over 6, same thing. I like writing the pi on top, so I know that the pi goes on the bottom when I'm doing this conversion. Okay, I can even cross cancel here. I could have cross canceled here if I wanted to too, but I can cross cancel here too. 6 is a factor of 180, right? 6 goes into 180 30 times. So if I cross cancel the 6 and the 180, I get 7 times 30, which is 210. And on the bottom, I just have a 1. Oh, forgot that degree symbol again. So we get 210 degrees. Now, a quick note, many of the angles that we look at that are in terms of radians have a pi with them. They don't have to, okay? So if they're talking about theta and theta is 1.4 and that's all it says, the lack of a unit, okay, is an indication that this is radians. So even if you wanted to convert something that had no pi value with it into degrees, you could take 1.4, and again, radians, times, we would still do pi over 180, but obviously at this point, the acceptable answer for something like this would be a decimal. So when you type this calculation into the calculator and you get whatever your decimal ends up being, okay, that would be, well, I can't even wager a guess at this point, but whatever it ends up being, 90 something maybe. Yeah, maybe in that neighborhood. Okay, whatever this ends up being as a decimal, that's your answer. It's okay to have radian measurements be decimals. Most of the time they have pi, but they don't have to. Okay, just keep in mind that conversion rate always works, whether it has pi or not.